All right, now we're going to look at solving inequalities. And exactly like solving equalities, our steps are exactly the same. So practice the exact same things that you've been practicing while you are solving equations. There's only one minor thing that's different, and we'll look at that in a minute. And also, the other thing that is different is that when we solve equalities, we get just one number. Our x equals this number. But when we have an inequality, that means we're solving where x or c or whatever letter we're solving for is a range of stuff. It's a whole bunch of numbers. All the numbers between this one and that one can work for this problem. So we get a range, okay, an interval. All right, so here's our sign. So step number 1, are there any denominators? Nope, so I don't need an LCM. Are there any decimals that we have to get rid of? Nope. So step number 2, simplify everything on each side separately. So we'll go ahead and do that first. You might want to turn this off and try it yourself first, then turn this back on and see how well you did. So 9c plus 24, 14c plus 2. Still not done simplifying because I have these two that I can combine. So 24, 17. And I have these two I can combine. Okay? Next step now, get my variable terms on one side or the other of the sign and keep them positive if possible. So in this case, we want them on the right side because when this comes across the sign, just like if it was an equal sign, then its sign changes, he'll be negative, and this guy who is positive is still bigger. So we want this one on this side. So that's 5c minus 3. Next, we want to always focus on the variable term. So I want to get this guy by himself. So that means take this and put it on the other side. When he goes across the sign, his sign will change. He becomes positive. Add those two together, and I get... Now get the c by itself, and I get... Okay, before I do this, I want you to say this. See how you do. Turn the video off, you say it. Then see if you say the same way I do. 4 is less than c. Or we could start with the c and say it this way. C is greater than 4. Or you could say c is bigger than 4. All right, so this is called algebraic notation. I don't care if you know that. I don't ever need to hear you say this is algebraic notation. You are going to get this answer every time no matter what in this form. What you do need to know though now is we're going to graph this and we're going to put it into interval notation. Those are two other ways of showing the same thing. Be sure to always graph it first because doing your interval notation is always way easier from the graph. So all I need on here, because we all know how number lines work, so I don't need all those tick marks and where 0 is and all that kind of stuff. Somewhere on here is a 4. Next, I need to figure out, is this going to be a parenthesis or a bracket? So I need you to think about which one it's going to be. Let's talk just a minute about if our symbols are just greater than or less than, then we use a parenthesis because our number is not included. If, however, our symbol also has the equal to as well, then we use a bracket. So one thing I like to do, if I put my finger over this and look at this, it looks like an equal sign. Equals means that number is included. Also, this is a straight line, and so is this. Maybe that will help you know when to use a bracket. If you do this, it doesn't look like an equal sign. Okay? If the number is included, so 4 equals 4, that works. 4 is less than or equals 4, that works, that kind of thing. We have to know where that number is. So infinities, negative infinity and positive infinity, can never ever have a bracket next to it because we can never have any idea where infinity is. As soon as we think we get there, it goes on somewhere else. Okay? So we can actually, in interval notation, have both a bracket and a parenthesis at the same time. Let's go back to our graph. We're trying to figure out here, are we going to use a parenthesis or a bracket? A parenthesis, because this is not also equal to. Now I need to figure out which direction this is going. So I need to think of things that C can be. Well, since C is bigger than 4, C could be 5. It could be 6. Could be 7. Could be 8, etc. So now I'm going to the right, not to the left. So then I'm going to put my parenthesis there, and C is going all the way to infinity. So I color that in a little, put a, wow, that's interesting, put a arrow. That arrow means that C is going all the way to positive infinity, because we have positive infinity on this side, negative on this side. Now, I've got my graph. Now it's easy. From here, interval notation is just the left end point, as far left as our C can go, and as far right as our C can go. So, as far left as it can go is 4. The comma between means everything between these two. As far right is infinity. Sorry, I can't do the infinity symbol. Math teacher, not an art teacher. This is already a parenthesis, so that's what's going to go next to the 4. And we just said an infinity can never have a parenthesis or a bracket by it. It always has to be a parenthesis. So this is algebraic notation, your graph, and the interval notation. Let's look at this one. Okay? Step number 1, does it have denominators? Oh, yes. Which means we need an LCM. Again, why don't you turn off the video, see if you can do this first before me, then come back and see how you do. So, our LCM is 6. Now remember, when we write this, sign, LCM, term in parentheses. Sign, LCM, term in parentheses. For however many terms I have. So our sign in front of this is positive, so I don't need to write it. LCM, term in parentheses. Now we're on to the opposite side of this, so we look at the sign again, also positive, so I don't need to write it. LCM, term in parentheses. Sign, LCM, term in parentheses. Now we can cross cancel. And the whole reason we do this is to get rid of our denominators. Remember that? Same here. So, I'm dividing both of these by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. I'm going to divide both of these by 6. 6 divided by 6 is 1. 6 divided by 6 is 1. Going to divide both of these by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Be sure, the next step, you're going to multiply these two. 2 times 8. Do not multiply them and try and distribute them all at once. that usually messes us up. So just multiply it and write this down. We still haven't done anything with him yet. 1 times 1k is k, and 2 times 8 is 16. Okay, now the next step. Simplify everything on each side of the equal sign separately. Well, I have nothing on this side to simplify, but I do have some stuff on this side. So 32k plus 16. Next step, get all of my variable terms on the same side of the sign. Keep them positive if possible. So on this time we want to put it on the left side. So when this goes across the equal sign, it becomes negative. Well, 32 minus 1 is 31. Now, we need to get our variable term by itself. So I need to get rid of him. He needs to go over on the other side. What happens when he goes to the other side? His sign changes, and these are gone. 16 minus 16, 0. Now remember, do not freak out and go, oh, this must be no solution. No, we still have a variable here. All of our variables did not go away. So don't look at this. Focus on this. What do I need to do with this to get the variable by itself? Divide by 31. If I do that on one side, I have to do it on the other. And 0 divided by 31 is 0. Okay? I'm going to rewrite this up here. Say this before I do. K is less than or equal to 0. Okay, another way to say that, K is smaller than 0. So let's go ahead and graph this. Okay, so somewhere on here is 0. And now I need to decide, the next thing is, when I figure out which direction it's going, am I going to use a bracket or a parenthesis? Well, this is also equal to. And if it's also equal to, then we use a bracket because it's included. So, now let's think of some things that K could be. Well, could K be 1, 2, 3? Oh, no. Let's go the other way. Could K be negative 1, negative 2, negative 3, negative 20? Okay, so yes. So we are going to the left. So we put our bracket, and it's going all the way to negative infinity. So there's my graph. Now I'm just going to take and make my interval notation right from that. So as far left as I can go, negative infinity. As far right as I can go, 0. Remember, we can only put parentheses by negative or positive infinity. This one's already a bracket, so I know a bracket has to go there, and there's my interval notation. Now, we're using the exact same steps that we do for solving regular equations. There's only one thing that's a little bit different, and that is when we divide by a negative. And I'm sure most of you remember, when we divide by a negative, we flip the sign. But that's not quite the way it is. You have to be very, very careful. It's when we divide the variable term only by a negative number that our sign flips. So if I'm dividing the term that has the variable in it by a negative number, if I do that on one side, I have to do it on the other, then our sign will flip. But if I'm not dividing the variable term by a negative number, even if I'm dividing the other side with a negative, my sign doesn't flip because I didn't divide the variable term by a negative. So this one, the sign would just stay the same. And that's the only thing that's different from just regular solving equations.